Intermolecular forces are the attractions that exist between molecules. These invisible forces play a crucial role in determining how matter behaves around us. Unlike the strong chemical bonds that hold atoms together within a molecule, intermolecular forces act between separate molecules, influencing everything from the boiling point of water to the properties of biological systems. Let's start with a clear definition. Intermolecular forces are forces of attraction that exist between separate molecules. The key word here is between. These forces don't operate within a single molecule, but rather pull different molecules toward each other. Think of them as the invisible glue that holds collections of molecules together in liquids and solids. It's important to distinguish between two types of forces. Intramolecular forces are the chemical bonds within a molecule, like covalent or ionic bonds. These hold atoms together to form molecules. On the other hand, intermolecular forces operate between separate molecules. They're much weaker than chemical bonds, but they're essential for understanding physical properties of substances. Intermolecular forces have three key characteristics worth noting. First, they are weaker than chemical bonds. You need much less energy to overcome intermolecular forces than to break chemical bonds. Second, they determine physical properties of substances, like whether something is a solid, liquid, or gas at room temperature. Third, they significantly affect boiling and melting points. Stronger intermolecular forces mean higher temperatures are needed for phase changes. There are three main types of intermolecular forces you need to know. First, dipole-dipole forces, which occur between polar molecules. Second, hydrogen bonding, a special and particularly strong type of dipole-dipole interaction. And third, London Dispersion Forces, which are present in all molecules but are the only intermolecular forces in nonpolar substances. Each type has unique characteristics and strengths. These three types of intermolecular forces differ in strength. London Dispersion Forces are the weakest of the three. They're temporary and result from fluctuations in electron distribution. Dipole-dipole forces are medium in strength, occurring between permanently polar molecules. Hydrogen bonding is the strongest intermolecular force, though it's still much weaker than actual chemical bonds. Understanding this hierarchy helps predict how substances will behave. Intermolecular forces have profound effects on the world around us. They control phase changes and determine the state of matter at different temperatures. For example, water is liquid at room temperature partly due to strong hydrogen bonding. They also influence solubility and miscibility, determining which substances dissolve in others. Finally, they're essential for biological processes, from protein folding to DNA structure. Life itself depends on these forces. Now that you understand the basics of intermolecular forces, we're ready to explore each type in detail. In the following videos, we'll examine dipole-dipole forces, hydrogen bonding, and London dispersion forces individually. You'll learn how each force works at the molecular level, see examples of substances affected by each type, and understand how to predict their effects on physical properties.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.